Welcome to The Explainer. Okay, something just happened that is going to completely redefine the relationship between us and artificial intelligence. And we're going to break it all down right now.
For decades, this has been the big question, right? The holy grail in the quest for AI. It's not just about whether a machine can crunch numbers faster than us. It's about, can it do the things we thought were uniquely human? Creativity, that spark of intuition, making those wild logical leaps.
Well, in the third quarter of 2025, that answer became a huge, definitive yes. And look, this wasn't just another small step forward. This was a giant leap, a total paradigm shift. It's the moment a theoretical goal that's been around for decades suddenly became a reality. So, okay, let's get into exactly what went down.
Our story starts at the 66th International Mathematical Olympiad. And if you're not familiar, this is the most prestigious, most grueling math competition on the planet for high school students. Seriously, just think of it as the Olympics, but for your brain.
This is where it all happened. For the very first time, AI systems from giants like Google, OpenAI, and ByteDance didn't just compete, they actually matched the performance of the world's most brilliant young mathematicians. And this was the big moment, because we saw multiple AIs go way beyond just calculating stuff. They were showing real, creative, human-level reasoning on problems they had never, ever seen before.
So what does that look like? Well, it comes down to this number, 35 out of 42. Now that might just sound like a score, but it is so much more than that. That specific score, that's the exact score you need to win a gold medal, a prize that only the top 10% of the absolute smartest human competitors on Earth ever get their hands on. Okay, but here's where the plot really thickens. It wasn't just one AI that hit this score. It was 3 of them. They all hit that same magic number. But, and this is the really fascinating part, they all got there using totally different methods. And, maybe even more importantly, they had totally different ways of proving they'd actually done it.
So let's look inside these winning machines. How in the world did they pull this off? And why did this amazing achievement almost immediately get tangled up in a controversy about whether it was even legitimate?
Well, what happened is that the game completely changed. As these AI models started hitting human-level performance, the competition wasn't about what they could do anymore. When everyone can climb the mountain, the new race is about proving how you got there. It became a battle for trust, a battle over who could verify their results in the most convincing way.
And this is where you see this really interesting strategic split. On one side, you have Google DeepMind. They took the slow, steady, official route. They had their model graded by the actual IMO judges to build what they called a moat of legitimacy. Totally ironclad. Then you have OpenAI. They went for speed. They put together an expert panel of former medal winners to validate their score unofficially. Faster, but not quite the same official stamp. Turns out, Google's slower strategy really paid off. They got this incredible endorsement from the president of the OMIO himself. Getting that kind of stamp of approval from the institution itself, that's a huge win. So let's talk about the tech that actually made this possible.
The magic ingredient behind all of these systems is something called neuro-symbolic integration. Basically, it's a hybrid approach. For a long time, AI was kind of split into 2 camps. You had neural networks, which are great for pattern recognition and intuition, and you had symbolic systems, which are all about hardcore logic. The big breakthrough here is that we're not choosing between them anymore. We're fusing them together, getting the best of both worlds.
So if we look at Google's deep think paradigm, it's pretty wild. They aren't using some custom-built math machine. Nope, they're using their main Gemini model, their generalist LLM, but they're basically supercharging it. They give it way more time to think, letting it explore thousands of different potential solutions all at the same time. It's almost like having a whole room full of brilliant mathematicians brainstorming in parallel. ByteDance, on the other hand, went a completely different way with their seed prover system. They set up this really clever student-teacher dynamic. The AI student tries to write a proof in a super strict formal language called Lean. Then, a computer compiler acts as the teacher. It instantly checks the proof and says, yep, that's right, or nope, try again. This creates this incredibly fast feedback loop where the AI just learns and refines its strategy over and over.
Okay, so winning a math competition is cool, right? But this is about so much more than that. These new reasoning abilities, they're already starting to create waves that are reshaping science, security, and entire industries.
The key thing to understand is that being able to solve super complex math problems is really just a stand-in for being able to solve complex, real-world problems. I mean, think about it. This kind of reasoning is the foundation for everything from physics and engineering to cryptography. So if you can suddenly get way better and faster at that, well, you can accelerate basically everything else.
And if you want proof of that, just look at DARPA, the U.S. Defense Research Agency. They're not looking at this as some fun academic project. For them, it's a matter of national security. Their stated goal is literally to develop an AI co-author that can help humans make mathematical discoveries faster. That's a huge deal.
All right, let's make this super concrete. Think about aerospace engineering. When they want to test a new aircraft design, they have to run these incredibly complex simulations of how air flows over the wings. Traditionally, one of those simulations can take hours or sometimes even days to run for just one test.
Now, get this. An AI surrogate model, like one that was used in a case study with Airbus, can do that exact same work 10,000 times faster.
We're talking about compressing an entire research and development cycle from hours down to milliseconds. What that means is engineers can now test thousands, literally thousands, of different designs in the same amount of time it used to take them to just test one. It's a complete game changer.
And of course, progress like this is being fueled by an absolute fire hose of money. Just look at the latest numbers from the Stanford HAI report. In 2024, private investment in AI in the U.S. hit a staggering $109 billion. That just massively dwarfs what competitors like China and the UK are spending.
So, when we look back, that moment in Q3 2025, it really marks a turning point. It's when AI stopped being just a really powerful tool and started becoming something, well, something much more profound. What we're talking about is AI becoming a true collaborative partner in the process of scientific discovery, and we're already seeing the results. In pure mathematics, these AIs are helping us crack problems that have stumped people for decades. In physics, they're spotting elegant solutions that human researchers might have just walked right past. But look, the journey is far from over. There are still huge challenges ahead. The next big frontier is all about building trust. That means we have to improve the reliability. Get rid of those AI hallucinations. We need to make them more explainable so we can actually understand how they're thinking. And, well, now that the IMO has been conquered, we need to come up with even harder tests to push them further.
So it leaves us with this big question, right? If AI is really our new research partner, what are we going to discover next? Because this achievement, it really opens a whole new chapter. This isn't a story about human versus machine anymore. It's a story about human plus machine. And with that kind of partnership, the potential for what we can discover, well, it's pretty much limitless.